Hello, my dear students. Welcome. In this session, we discuss about potential energy of the spring. This is the normal position of the spring. Fxa is 0, x is equal to 0. It is the normal position of a spring. And when it is stretched at the distance of x, this is the elongated position of the spring. Now it is the normal position of the spring, it is the elongated position of the spring. Now if the block is pulled through a distance x, the block is pulled through the distance x from the equilibrium position, the spring gets stretched, and due to elasticity a restoring spring force Fs is set up in spring. If the block is pulled through distance x from the equilibrium position, the spring gets stretched, and due to elasticity a restoring spring force Fs is set up in spring. So F is directly proportional to minus x, or F is equal to minus kx, where F is equal to spring constant and negative sign that is act in opposite direction. Now k is the spring constant. What is k? K is the spring constant, and the negative sign shows that it act in opposite direction. So to keep the spring stretched by a distance x, to keep the spring stretched by distance x, an external force F equal and opposite to Fs. To keep the spring stretched by distance x, an external force F equal and opposite to Fs act on it. F is equal to minus Fx, so is equal to plus Kx, where F is equal to Ks. So F is equal to minus Ks, so minus plus Kx. The small work done dW is equal to F dx, so equal to F, as the place of x we put Kx into dx. Now W is equal to K is constant, so we integrate x dx. So K, after integration, use the formula x as the power n dx, so x n plus 1 by n plus 1, so we put k 1 plus 1 by 1 plus 1. As we use x n dx is equal to x n plus 1 by n plus 1, so at the place of x 1 plus 1 by 1 plus 1, so kx square by 2, or W work done is equal to half kx square. The work done is stored as a elastic potential energy U of the spring. Now the work done is stored as the elastic potential energy U of the spring. So U is equal to half kx square. Okay. Now after that we discuss about conservative and non-conservative force. We discuss about conservative and non-conservative force. A force is conservative if the work done by the force in displacing a particle from one point to another is independent of the path followed by particle, and it depends upon the position on the end point. As I will simply say, the conservative force is that which is independent of the nature of path, and it is डिपेंड अपॉन द पोजीशन. कोई भी फोर्स जो कि पोजीशन पे डिपेंड करता है, पाथ पे डिपेंड नहीं करता है, इस तरीके का फोर्स जो होता है वो आपको कंजर्वेटिव फोर्स कहलाता है. ए फोर्स इज कंजर्वेटिव इफ द वर्क डन बाय द फोर्स इन डिस्प्लेसिंग ए पार्टिकल फ्रॉम वन पॉइंट टू अनदर इज इंडिपेंडेंट of the path followed by the particles and depend only on the end point. As for example, the gravitational force is the conservative force, the electrostatic force is the conservative force, So a force is conservative if the work done by the force in displacing a particle from one point to another is independent of the path followed by the particles and depends only on the end points, as for example gravitational force, electrostatic force, etc. Now, if the amount of work done in moving an object if the amount of work done in moving an object against a force from one point to another depend upon the path along which the body moves, then such a force is called non-conservative force. ऐसा फोर्स जो कि पाथ पे डिपेंड करता है, उस तरीके का जो फोर्स होता है वो आपको कंजर्वेटिव फोर्स कहलाता है। आपको फ्रिक्शनल फोर्स जो है वो आपको एग्जांपल है आपको जो है नॉन कंजर्वेटिव फोर्स का। ऐसा फोर्स जो कि पाथ पे डिपेंड करता है, पोजीशन पे डिपेंड नहीं करता है, तो इस तरीके का जो फोर्स होता है वो आपको नॉन कंजर्वेटिव फोर्स होता है। नाउ इन द अपकमिंग नेक्स्ट सेशन वी डिस्कस अबाउट मोर थिंग्स। ओके, टिल देन गुड बाय, हैव ए नाइस डे, थैंक यू फॉर